Yeah, we can start. No issues. Okay, done. Okay, done. Yeah, thank you very much, Surya. Thank you very much for the introduction. So, hi guys. As Surya said, I'll just give a gist about myself as well. So, myself, I'm working as a senior embedded engineer in Johnson Electric. So, currently, my work is based upon the motor controls and developing the IoT edge devices and all. So, yeah, I'll just share my screen so that I'll just share my PPT as well. If any doubts are there or any concerns are there, you can just raise a question in the chat. At the end of the session, I'll just try to come back to that questions as well. Okay. Yeah. Yeah. Everybody can see the screen, right? So yeah. So I'll just start with basic. I mean, the basic question of who, like basic question what everyone have it. So starting with what is an embedded system and why we need it. So see, the basic definition of the embedded system is always subjective. It depends upon what is the solution that we provide or what is the solution that we make and all. So at present, according to whatever the expertise I have gone through or whatever the experience I have it, so embedded system is a collection of various components which can be hardware or software or mechanical to provide a solution for an existing problem. So that's the brief definition of the embedded system which I have been gone through. Because if we take a real life examples like AC or washing machine, like every one of you have heard about these embedded systems like which we interact with every day to day life. So if we take AC, so AC is just like the problem here is like the heat, and the solution which AC provides is the coolness of the room. It's a simple problem and solution method. So if we take a washing machine to ease our work by works for us, and yeah, so why do we need an embedded system? So if we discuss in a broader view, it's just to make life simple. Whatever it is, it can be, you might not interact with that particular system directly, or maybe it is a part of your daily life, everyday life, which eases you. You are going on a bike, you are checking some you are checking a speed, how much speed you are going on a vehicle. So that is also an embedded system. If you are going on a car, you are applying the power steering or the braking or the hill ascent and descent controls, like whatever the feature which you are interacting in nowadays. All this comes under the category of making the life of a particular user easy. So this is about the broader view of embedded systems. So moving on, the next one is so what is basically the components of embedded system? Like all these are basically we'll be going through. in your college, but I'll just give a gist about it. The most important things and most important part which need to be discussed in detail is about the software development life cycle of the particular. Everybody can see the PPT, right? I didn't ask the question before.
Yes, sir.
Yeah. Okay. So the basic components of the embedded systems coming to that simple. It's like the input, processing, output, and if any user interface is there, the user interface. So this is the basic components of any embedded systems, even if it is advanced or even if it is a basic embedded system such as you can say a relay driver or something. So basically, it will have one input, one or multiple input. The embedded system which process the data by taking the sensors or the inputs, and it is going to give us some valid output, which at the end interact with the user. So, what is an input in a embedded system? It can be anything. It can be an analog sensor, digital sensor. It can be a thermostat. So, if we take example of AC, as I said, so it is going to few ACs will have feature like automatically adjusting according to the climate, or else in the cars, if we take automatic climate control. So, it basically have some analog or digital sensors which interact with the atmosphere. It is going to get the temperature, how much it is going on outside, and it is going to give us the real time analysis of the particular climate, and then according to that it is going to control the AC inside a car. So basically that is an input. And moving on further, uh, so we got the input now, and then we are giving that particular input to the CPU. CPU is nothing but a processing unit which we will be processing some data. So let us take an example of we will do one thing. We'll take an example of weather monitoring unit. So it's a project which I have worked on in my field of experience. So weather monitoring unit basically it the project which I have worked on is components of weather parameters that need to be monitored. Like in the BTech level, yeah, you guys could have came across a weather monitoring project which everyone have done it. So basically, you guys will take temperature sensor. I mean DHT11 sensor probably everyone have taken. So it will have moisture, temperature, and you can take the raindrop sensor to detect the rain, but it will not work in the real life world. So we will have industrial grade or industrial standard sensors which we need to consider while developing a system. So for a weather monitoring unit, we have sensors like CO2, you can say NO2, CO, and carbon monoxide, and the ozone level of the this thing, and noise validation. I mean noise measurement. You can say one more thing is dust. How much dust is going on inside, and what is the temperature? Of course, temperature will obviously be there in a weather monitoring unit, and then all this will be processed, and then it is going to send some data to the some we will come to the output, like what is the output of that particular, we will come to that later. Then so these are all the input parameters for a weather monitoring unit. Then that input parameters are going to be given for particular CPU. So let us take an example in a BTech level project, like you can say Arduino, or you can say Raspberry Pi. So interaction will be I2C. I think few people have you heard about I2C, SPI, and UART. So these are the basic communication protocols which will be used in an embedded system. So all this data is going to be given to a particular CPU. CPU is nothing but a microcontroller or a microprocessor or anything. So in our the expertise which we have in microcontroller, we have it. So all the certain parameters are going to be given to a controller. But how 13 parameters are going to be given to one single controller? I mean, it's huge, right? 13 parameters. You can't have 13 I2Cs. You can't have 13 SPAs, or you can't have 13 UARTs. So how a system is being built for taking that many parameters? So all this comes under the system development of particular problem. So what problem we have currently is weather monitoring. So while monitoring the weather, we need 13 parameters. So we know 13 sensors will be there which will be monitoring all the data. So how we develop the hardware or how we develop the firmware is depending upon the system analysis or the hardware analysis. So that comes where what kind of controller we need to take, or what kind of sensor we need to purchase, or what kind of hardware we need to develop and all. So that is what CPU is about. So it just take the data from 13 sensors, process it, and give some particular output, which is ultimately given for the user. And then we have a memory unit. So memory, why we need a memory unit inside an embedded system? So for saving the events which occur in particular embedded system. Why we need to save in events? When we have a particular communication protocol sending outside the data whatever we read, why we need to save the memory? There can be various reasons, including you can say the communication part of the particular hardware is not working. So basically what happens in the lab point of view, if we take, developing an embedded system is easy. You will have all the parameters under your control. But once you take your embedded system outside, so there will be no control over your embedded system. You don't know what is going on there. All the communication which is happening outside is depending upon some provider, like for example, let us say Jio or Airtel or BSNL. So they will be providing us the fiber, and we are going to use that fiber. So we can't really say how much reliable that can be. Obviously they'll be reliable only because that's why we are able to communicate through online. So there can be some power breakages or power outages in that particular system, and we can't keep all of our embedded system on a battery. Maybe you guys could have, I mean, anyone could have got idea of keeping whole embedded system on the battery and run it when the power is not there, but that is not the case because batteries also have certain limitations, and we can't keep batteries on every embedded systems. So we need a memory unit to save the events, important events. So for example, there is a short up in CO. So there is some fire accident happened nearby, maybe, or the traffic got increased in the evenings, or something happened, and CO got increased to certain level which we can imagine. So that is an event which is going to be sent outside or displayed on the user interface. So that kind of events we are going to save it in the memory unit. So memory unit is basically a place where we save the events. And I am not discussing about the memory unit where the code is going to be saved. That I am including in the controller itself, the central processing unit itself. So I'm not discussing about that memory unit. I am basically talking about memory unit which is needed to be used to save particular events which occurs. And then the next component which we have is bus interface control unit. This is a very advanced term, but in general, it can be some, I can say this as a communication interface which can communicate to the outside world. So I don't want to go as advanced into what is inside what is a bus, what is the interface, why we need to control it with the CPU. I'm not going more deep into that. I'm just going to explain how this particular embedded system is going to communicate with the outside world, and to communicate that, we need a bus interface or the communication interface controller unit. So which is going to communicate. So I will tell you an example of. I think you guys have heard about NIC, right? NIC is a network interface card inside a CPU, which we use for Ethernet or Wi-Fi or anything. So these are the external components to the CPU or the controller. These are not the internal parts of the controller. See, basically, a controller will have only a part where it can process and send the data outside. But it can have peripherals like UART, I2C, and SP, but it cannot contain all the components which is required for high level peripherals such as Ethernet or Wi-Fi. So for that, we need some external controller, which we need to communicate using some other advanced peripherals like MDIO, MDC. Like you will come across while working in an industrial internships, or if you start working in an industrial company. So then you will get to know what is this different chips what are available. I'm clear, right? Like if you have any confusion, you can ask me a question, or you can raise a chat question or anything. So basically, bus interface is like a communication peripheral which will send the data outside. So what is an output? This output can be anything according to the system. So let us say this weather monitoring unit need to monitor some parameters such as CO2 and CO. If that particular CO or CO2 levels reaches some extent, we need to start some room freshener or room air freshener. So let us say the CO and CO2 levels got increased and we need to purify the air. So it need to start a air purifier which is there at your home. For example, let us say this weather monitoring unit is indoor. So then we need to start air purifier. So for that we need some relays or some way of digital connection or some way of digital path is needed to start that particular air purifier. So it can be a relay. Simply, it can be a switch. So how we are going to use that switch? That kind of things will come under as output. So it can be command driven. Command driven in the sense a user can choose from a mobile app to start that particular air purifier, or else we can code. We can write a firmware or software inside an embedded system, so that we can understand or we can understand the inputs which we are taking like CO and CO2 and then process it and then deliver some output. So other output which can be there is, for example, is like a Ethernet, which is which is a communication. It's like a communication to the outside world. So, for example, let us say there is a chitty for city for Dehradun. We need to connect to the internet, and we are going to send or push the data. Sorry. Oh, okay. 1 minute. Just a minute. Now am I audible? Hello. Now it's fine, right? Okay. Just a minute. Yeah. So that's what basically the components of embedded system. So you guys have to understand, depending upon the problem, we need to choose what are the inputs, what are the processing which we need to do, and what are the outputs. So this is what any embedded system, or you will be doing some projects or anything. So this is how start thinking. So whenever you are going to make a embedded system, we need to understand what is the inputs for me, what is the processing, and what is the output. So before giving awareness on the what are the kinds of opportunities which are there on embedded system, I'll just briefly tell you the total design or the product. I mean the product development cycle from in different phases. So basically, any embedded system development or any product development cycle will have these 7 phases, including the hardware and software developments. So starting with the requirements. So whenever we are going to create an embedded system, or whenever we are going to start or take a we have a customer, or let us say we will not discuss about the customers and all. Let us say we are going to do a project. So for our project, so what is the project that we are going to do? So let us take an example of same the weather monitoring unit. So here weather monitoring is a unit is a system. So a system will have certain requirements. So all the requirements need to be taken care. So that will come under phase one. In the phase one, we are going to have product specification, which is given by the customer or by yourself or anything, whatever the means it is necessary. We are going to get some requirements. So weather monitoring will have, we need to monitor certain parameters and we need to send it to the cloud. That's what our requirement is. Now the system have requirements, and now we need to divide the hardware and software developments. So this is where the critical part will be there in any system development. We need to identify, we will have a requirement like monitoring CO, but to monitor CO we need particular sensor and we need particular interface to program. We need particular hardware to develop for communicating with that CO sensor. So how we are going to divide the hardware and software requirements? So that hardware and software partitioning will come under this phase two, where we get the requirements of the system or the project, and that we are going to distribute what hardware we need to procure and what software components we need to write. So in any industry or any industry, we will have different teams. So one team is going to procure the hardwares, which is basically a marketing team or sales team, which they will give or take the requirements from the customer and give it to the system team. The system team is going to list down the all the requirements given by the customer, and that is given to hardware team separately and the software team separately. So now what will happen? Hardware and software development will go parallelly. That will come to the later part, like in phase 4. It's in phase 4 how we are going to uh, develop the hardware or software. So in the phase 3, iteration and implementation. So simply we have partitioned the hardware and software, that's fine. Now we need to add a new requirement given by a customer or developed by us. So weather monitoring unit, first we thought, okay, we are going to monitor CO and CO2, but later on we got added, we need to add NO or let us say noise measurement, we need to add. Then again in the phase 3 we are going to redefine or re-review whatever the requirements we have done, and then we are going to take note of that. Again we are going to give hardware and software partition. Again we are going to phase 3, then we are going to phase 4. I'm clear, right? So till here it's like system requirement, system development life cycle. I mean, not life cycle, it is a till 3 phases. Now comes the hardware development life cycle. Actually, I am discussing hardware first and for software later, but in the industry it doesn't work like that. Hardware and software will go parallelly. So there is no link, there is no particular flow that hardware should be given or hardware should be developed first or firmware should be developed first or software should be developed first. So I am just discussing the hardware as the first. So now we have hardware requirement specification. So now we have particular hardware that need to be developed. So that we got it from the system level or system team. They said, okay, you need to develop a hardware to interact with the CO2. Now the hardware team need to analyze what CO2 or what are the parameters which we need to monitor. So we have, as of now, 3 parameters I am taking for the simplicity of explaining: CO2, CO, noise. So now the hardware team need to analyze what kind of you say what kind of sensors we need to buy, what is the range of the sensor the customer is required. So all this the hardware team need to analyze and select one particular product that will suit the requirements. Then the hardware team is going to do the feasibility and market study and BOM optimizations. BOM is nothing but bill of materials, and feasibility and market study are like what are the fast moving components which are there in the market. So not all the sensors which are available in the market we can't procure. So there will be a particular sensor which have all the 3 components in one single go, but that is not a fast moving thing. We have some other sensors, 3 different sensors, but they are very fast moving and available all the time. So the hardware team need to decide what kind of product or what kind of sensor we need to integrate in our system, and what is the interaction of the controller and the sensor, what is the communication protocol between them, that need to be analyzed, and they need to provide some kind of design. This hardware design is nothing but block diagram view of everything, and it includes schematic and PCB designing and layouts. So, see why I'm trying to explain you all this, because I want you to give an awareness of what kind of opportunities are there in the market for the embedded field. Embedded is not a uh, one single job. It's a group of jobs together combined and developing one single product. So if we take here, for example, the hardware designer is one part, hardware layouts design is one part, and system requirements analyzer is one part, and maintenance is some other part. So we have multiple opportunities available inside the embedded systems. Okay. So now what the design includes, the schematic is nothing but the connections of each component. So in the weather monitoring unit which we took, so we took three different sensors, and one sensor work on I2C, one sensor work on UART, one sensor work on SPI. So all these three different peripherals need to be interacted with a controller. Let us say Arduino we are taking. So Arduino need, whether we need to confirm Arduino have that particular peripherals or not. We can't take any controller. We need that particular controller which is suitable for our requirements. Then comes, after the hardware and layouts design, then come the implementation. Here the implementation is nothing but, you can say, the board, so soldering, assembly, manufacturing, PCB manufacturing, component procurement, all this comes under, this will go out of the scope of the engineer. This will go under the production people, which will be after the engineer. So we develop till the layouts, and we are going to give it to the purchase team. So that purchase team is going to interact with various other vendors or other communication other people who who make our design into the real life component. So PCB fabrication will have one kind of approach. They'll have few kind of companies which will fabricate the PCB. Board assembly is nothing but, so we have developed a board and all the components need to be placed on the board. So it's nothing but board assembly. Component procurement is like previously as I said, we have different sensors or different sensors which need to be monitoring different parameters. So we need to procure all the components which are needed for our system. Then what, after the implementation we got a board. Then what need to be done? We need to test it. We need to verify whether whatever we have designed is valid or not. So the controller will have certain program need to be written. So that program we need to test it. We need to communicate with all the all the sensors. We need to get the data from them. We have to just print them out as a testing purpose. Here there is no firmware development involved or firmware. See, I'm using firmware and software as a interchangeable terms, because in embedded system few people call it software and few people call it firmware. So testing and integration, the hardware team only is responsible for the all the components to be working. Then comes the maintenance. This maintenance is not in the starting phase. This maintenance comes after the complete product development. So after the testing done, we need, if the testing is working fine, then we develop the firmware and software. After the flashing, after it go to the site, then we need to maintain site in the sense the outside world. Then we need to maintain the hardware. Some issues comes, then they'll come back to us again. We need to change few things again. We have to bring up new PCBs, like that. Am I clear till here? You guys can chat here. You can ask questions in the chat. I will answer them. If any kind of questions are there, I'm free to that. And next comes software development. I think the heading is a little bit wrong. So here it's a software development. Same like hardware, we also have the software. So there also we get software requirements. So what, for a weather monitoring unit, what is software requirement? We have different sensors which need to be integrated. So the software team will get, okay, you have one sensor communicating over I2C. You have one sensor communicating with the UART. You have one sensor communicating with the SPI, and that data sheets will be given to the software team. Then the software team will analyze the resources, identify the resource which the controller have, and then they do the test plan as well. See the what the most mistake according to, like, when I came out of my college as a student, or maybe what is going on right now also, people think the testing comes after the development, but actually the testing comes before the development of the code, and the design comes before writing any code. In our colleges or anywhere, we always come across situations like they they say us the code, we'll code it, then we're going to test it. But the process is we need to write down all our test requirements. So for example, we have a sensor, we need to write down our test case. Okay, we need to get this data. How we are going to get the data, and what is the expected result, and what is the actual result. So to prepare this test plan also, we have a job opportunity outside. Okay, so it come under validation and verification. uh, so yeah, so here in the analysis only we need to identify the resources we need to use, hello, am I audible? Okay. Till where you guys have stopped, can you just tell me? The analysis part is audible to you? Okay, I think I'll start with the design as well then. Am I audible, right? Right now? Okay. So I'll start from the design again. So so here the design is like all the parameters that we need to consider, all the design, all the timings we need to consider, like how much time we need to scan the data, or what is the considerations we need to take, or what is the time we need to scan the data, and then we are going to process it. What is the process that we need to do? For example, let us say we are going to do an event driven system. Event driven system in the sense, only if there is an event. So let us say the CO level have increased to certain level, then only we want to create some event. So it's called event driven system. So that event driven system will generate an event only after certain event occur. So that we need to consider, we need to take into consideration. I think I'll just stop here for 1 minute. Everyone is catching up with me, right? I'm just keep saying it. I can't get any feedback or anything which I can need to repeat again. You can message me on the chat. Any questions are fine. See, I'm not too much superior to you. I'm not like, I don't want to bore you guys. We can discuss. No issues. Okay, we will just move on. Maybe in the last we will discuss if you guys are having any doubts. I'm always open to questions. Then the implementation part, simply like writing a code. It's nothing more than writing a code. And then comes the testing and integration. This is again the important part of any system. Implementation I'm not discussing much because it's just a coding. We just have some peripherals, we just have some C knowledge, everyone can do it. We just need to understand few implementation techniques, or it completely depends on the independent individual only. It's not nothing to be discussed much. So testing and integration, again we have a testing person. So we have, if you remember correctly, we have a test planning document. So this test plan document is going to come into picture in the testing and integration. And what is this integration? Testing is okay. What is integration? So let us say in an industry we have a teams. So one team is going to work on CO sensor, one team is going to work on CO2, what one team is going to work on noise, noise sensor. So all these teams are going to integrate. So for the integration, there will be some separate job opening again, integration engineer. So he is going to get the code from all the three of the teams. He is going to integrate and give it to the processing. So again, the process will be some separate thing. Again, the output will be separate thing. So integrator is responsible for combining all these components and giving one particular code or a C file. So then that particular person, maybe it can be the same person or else some other person he is going to test our embedded system according to whatever is there, whatever the plan we have made. And again, maintenance, as I said, so we are going to get some bugs, huge bugs we are going to get it. So again, we are going to change the code, maintain the versions, keep on updating ourselves. For if some particular library, let us say in the Arduino we took, and we have a Wi-Fi module, and if that module is updated by the source, whoever have done it, then we should update ourselves, because there might be some bug in this particular version which we don't know. So we need to keep on maintaining that. Am I clear till there? Anyone can respond or anyone can message. Okay, then I'll continue. So we understood what is an embedded system and how the process of an embedded system. Now, how to think like an embedded engineer. See, I'm not mentioning here embedded developer. It's an embedded engineer. So embedded engineer can be anyone who can test a system, who can develop a system, who is designing a system, who is taking the requirements of a system. So no one, everyone comes under embedded engineer only. So starting with, think about a system and not a technology. That means you only think about how efficiently you can develop your own system. No one need to think that what kind of technology I should use. AI only to give my system optimal performance. I need to use ML only to give my system highest performance. Or you don't need to think that I need to use the big drivers, or I need to use function pointers, or this kind of things are immaterial for a system. So if you are going to develop a project, you one must think only what is my inputs, what is my processing, what is my output, and how best and how optimally I can build it up. So one might think while developing an industrial, which I have also faced in my BTech. I also have thought like this only. That's why I am mentioning this as first. I used to think I can't make a embedded system by using Arduino or Raspberry Pi. But my first project coming to the industry is based on Raspberry Pi. So they have developed a security system based out of a Raspberry Pi. So there is no system which need to be developed only based on the third party or the big manufacturers like NXP or Texas Instruments or this kind of controllers only. So whatever the system, just by using a 555 timer also we can develop the systems. So don't think about the technology. Then question everything, whatever you see. Even that's what lacking in the students, which I mean, even in myself as a student, I also lacking the questioning. Now I am, after coming to the industry in the first job or whatever you can say, I started learning that questioning is important for anything, everything. There are few scenarios where just the I used to, maybe we are getting a question but we are hesitating to ask a question. I came across that kind of scenarios where I thought maybe this question is not immaterial, but a 30 years old senior has have asked the same question which I got it. So that means whatever the question is, he didn't thought, okay, I'm 30 years experienced, so I can't ask this question. He just felt that that question need to be asked. He have asked. So question everything. It doesn't matter whether it is big or small. And we should an embedded engineer should accept what he don't know, and then set himself to learn them. So in this whole world, no one is perfect. No one knows everything. Everyone need to constantly learn to become an engineer. I mean, we can see outside. The first thing one thing I want to say is never think that engineering is not valid in outside world. Engineering is not valid for whoever is not going to the engineering field. I came across so many scenarios in my own field that in the BTech I felt this scenario is not needed. This subject is not needed in my future life. But after coming to the industry, that is the first project which I have worked on. It's WSN, wireless sensor networks. Whether I don't know whether you guys have the subject or not, but it is one of my elective. So I thought, what is this elective? I don't need to prepare much. We will not come across. But my first project is based out of wireless sensor networks. So accept what don't know and learn everything. Then one more thing which I have loved, I learned so much is unlearn to learn. We might know something, or our lecturers or teachers might have said something that we get fitted in our brain. But after coming to the industry, that is not the case. Maybe whatever they have said is correct, but whatever we understood is wrong. So we need to unlearn. We need to take out whatever we have learned and again learn the same topic again. And we need to understand what is the difference between what I have learned and what is actually there. And then other thing is there is no wrong solution. Every solution what we think or what an embedded engineer think is correct. But the difference will come in the optimization. If we are thinking a solution can cost 20,000. A solution can cost 1,000 rupees. So both of them are correct. Both of them give the best results or best performance. But the thing is the optimization and the cost. The same effectiveness which that 20,000 equipment is giving, you are going to give in a 1,000 rupee system. So that is the optimization of that particular example. And take feedbacks from peers, like take feedback from whoever is you are working with, or whoever is being with you, whoever is your friends or anything. And be a good listener. Listen everything before reacting. Listen whether what the other person is trying to say. Maybe we can understand that other person is saying wrong, but till the end listen to it. Maybe there can be a particular point which can make everything correct. So till the end we don't know what they meant. So we, or an embedded engineer should always be a good listener to develop ourselves in our own career. Next, coming to the career opportunities. So I have just broadly divided into three different levels. One is system level, one is hardware level, one is firmware level. And system level engineer, system engineer who takes the requirements from uh, the sales team or marketing team. He is going to execute them, and he is going to divide the hardware and the software. Like as I said, I have explained in the previous slides. So we are going to have hardware requirements separate, firmware requirements separate. So the system engineer is going to do that, or system architect is like who is going to develop the whole system. And there again the block diagram level of system is going to develop. So the system level engineers are little experienced point of view, I can say. System validation engineer with their compliance verification. What is a compliance verification? Nothing but we have different, you can see everywhere. You can, if you go to a market and purchase something, there will be ISO mark, ISO 9001 certified or something. So what is that? It is a certification. It is certificate given by international standard organization, given to a particular product, that this product is valid and this product have some compliance with what are the standards we put. So to verify that compliance, there is a job. And coming to the hardware, we have hardware engineer, layout design engineer. As we have this, we know hardware engineer is like schematic drafting. I think in the colleges there will be spice. I think that will be there to for the schematic drafting. And layout design, you can say layout design is similar to VLSI in that field. And coming to validation and test engineer, again, as we have discussed, there are testing and validation team which are going to test your embedded system whether the inputs and outputs are validating or not. And coming to the firmware or software level, we are going to have the firmware engineer. See, whatever is marked green here, there is an opportunity for a fresher to go inside. This is only according to my experience of 3.5 years or so. If only I can procure this much of experience, then imagine how many opportunities are there outside. So please don't think that embedded doesn't have any opportunities. Embedded do have opportunities, but everything depends on how we search. Because for us, when we are in the student time, there is no webinars or free webinars to teach us what exactly is embedded system or how to approach it. But now we have n number of resources. I am one resource of that. Maybe you can come across most best resources online. You can even ask our technical team in the SSIT. So they will also help in getting an internship or getting exposed to the embedded systems and all. So firmware engineer, firmware design engineer, validation test engineer. Again, here comes the compliance verification, because software will have compliance verification. Firmware integration engineer, as I said, we have different modules, and we are going to integrate that. Okay, these are the career opportunities in a broader view. And one thing remember, testing doesn't. I mean, no role is small. People are thinking that testing is a small job, or layouts or big job that we can get our career growth. So nothing is like that. Always it depends on the opportunities which are there outside. Okay. And thank you for your patient listening. I have been, I think, a boring presenter. I couldn't see much of a response from anyone. If you can ask, if you have any questions, I am up for the questioning. For we have more, I think, 5 to 10 minutes. We can discuss, or we can talk about the opportunities, or what, if you have any doubt technically, also I might help. Anyone is fine. It's great. Yeah. Yeah, thank you very much. I think we got, yeah. I have one doubt. As a fresher or experienced person in the other field, if we want to become firmware developer, how many months it will take to learn what is the right procedure? Okay, so being a fresher or experience in some other field. I mean, if the other field is related to C or anything related to this, if it is C, then it will take at least 1 month of testing and training on the particular controller. See, one thing I suggest is start with Arduino. If you are fresher or anything, start with Arduino, start with Raspberry Pi. So there you are going to get some experience on the embedded systems. That's how I have started. So starting with a small project called Smart Irrigation for it's like a concept. So there I have used different sensors, and I have uh, took some sensors and interacted with the Arduino. So there I understood how the sensors are going to interact. Then I went up to the Raspberry Pi. There I came across like how Raspberry Pi is going to communicate with some other peripherals. Then I went up to the Texas Instrument based chipset, something I don't MSC 430. It is you can get the STM32. These are all the development boards. Buy a one development board. See, we will be spending so much of money outside. Just spend that 1,000 or 1,500 something to get a board and start learning. Start experimenting on that. And if you are starting immediately, then within 1 month you can you can get a knack of whatever the firmware engineer or the firmware development cycle. You can get it. That's what one thing is. And one more thing you have asked, while designing hardware, do you choose the circuits? Does it based on data sheets? How to develop bug-free hardware? See, one thing I can say, first version is never a bug-free. So in my experience, I am saying, so first version will never be bug-free. And yeah, while designing the hardware, the thing we are going to go through is the data sheets and the application notes, which will be given by the vendor. So let us take for example, Texas Instrument is the chipset developer. So he is going to give a data sheet or application note of how to use the schematic, how to interact with that particular chipset, and he is going to give it. So depending on that, we need to design our own hardware. So yeah, and the bug-free hardware, it's questionable. Like if it's small thing, you can develop bug-free. If it's a bigger hardware, then bugs will be there. So we need to go for the other version. I think that might solve your question. Anything else?
Hello.
Hello. Yeah.
Good evening, sir.
Yeah. Good evening.
Actually, this is not some kind of technical question, but
Yeah, it's okay. Anything is fine.
y- uh, you explained about that one how to be a good kind of embedded engineer.
Okay. Yeah.
Currently, I'm working in that field with 8 months.
Okay.
So the point that you have raised, the way unlearn to learn and
Yes.
be
Yes.
good listener to our managers, our experienced to seniors. Actually, I also facing some lot of difficulties by growing and learning fast.
Okay.
So, can you tell me anything, something more for making learning fast? That subjects that we are faced in the industry.
Uh, I mean, I'll just ask you the same question which you have asked me. So you are facing some difficulty in your own self growth in the company which you are working on.
Mm,
So you want
yes,
to
sir.
learn more better.
Mm,
Spend some time after the office hours more. As I said, buy
mm,
a development board. ST will have the best examples online. STM32. So you will get so many STM boards outside. So there to you're going to get more examples where you are going to get more example of how to use particular HTML32. Okay, so what I'm trying to say is if your job or the role which you are feeling, if you are feeling in that way, see one more thing I will just suggest. I don't know the situation which you are in, but everywhere there will be some scope of learning. So always search for
mm,
the scope where you can learn and always improve yourself. So there will always be some scope for you to learn. If you feel that my job is not giving me any scope anymore, you create
mm,
yourself by spending more time after the office hours. At least it can be 1 hour or 2 hours. Buy some stuff, start experimenting on them. You don't buy already prevailing. I mean, where you can get more examples. But I can't suggest right now. I mean, I can't suggest as of now. But maybe I can help later on. So what you need to do is you need to identify uh, the board which have bare metal examples, like directly accessing the controller and working on it. So if you have that
mm.
kind of control boards, then you can work on the controller itself directly. So, for example, Arduino is you are not working on controller directly. You are working on some
Yes, sir.
software.
I'm working on test codes of controllers, test controllers.
Yeah, if you are working on that, then you can find some board. You can understand the register mapping. So find some HTML32. Start reading each peripheral. Go with each peripheral. Start with GPIO, then timers, then UART, then SPI, I2C,
Mm,
and buy some sensors to interact with them. So in this way, you can learn more better. I mean, this is my suggestion.
okay, sir. Thank you for your
Yeah,
suggestion. I also go through those ones
yeah. Once go through.
for boosting my this learnings.
I think in chat one thing is firmware coding the books for our websites to learn firmware coding. For the embedded, the firmware code. See, the first controller I have used is. I'll just message in the group. Just note that down. LPC 1769. So this is the controller which I started my career. So according to this controller, I can suggest one particular website. So OFC Freaks is one website which have given me much insights. So maybe you can refer to that. I'll just share that link also in the website. So this is sorry. I think I need to OFC Freaks dot. You can ask me questions in Telugu also. Okay. తెలుగు కూడా బాగా తెలుసు నేను తెలుగులో కూడా ఎక్స్ప్లెయిన్ చేస్తా కావాలంటే సో దిస్ ద వెబ్సైట్ విచ్ యూ కెన్ గో త్రూ ఫర్ embedded systems and one more thing Jacob textbooks I don't know textbooks we can also but much came across which are interested to me on firmware development because firmware development always depend upon the hardware which you are using it. Basic C if you know that will be enough to write application layer and if you want to interact with the controllers you need to learn the data sheets of that particular controller then only you will get more insights. This OFC freaks will help in getting that insights for LPC 1769 MSP 430 that it can help. You can go through that. Yeah, I think we can wind up the session. Yeah, yeah, definitely. Thank you for giving me the opportunity. Yeah.